So far, we have been using F# as a purely functional language, just using functions. But F# is also a full-fledged object-oriented programming language. And today we're going to talk about the object-oriented features of F#. Now, functions go a long way, and in practice, at least for me, in practice, I tend to use classes quite seldom. But that being said, without classes and object-oriented capabilities, F# would be an incomplete language. So these are important things, but you go a long way with just record types, union types, and functions and modules. But certain things are hard to do without objects. And for example, in F#, using classes will allow us to do overloading, polymorphism, and interfaces, type constraints, and other things which are not really available to us using just the normal function syntax. So these are important things. And in a way, it's a sort of a little bit of a matter of personal preference, whether you like to do function-based functional programming or functional object-oriented programming. I tend in practice to favor just using functions. I find that I get more flexible and more lightweight code that is easier to refactor and so on, and use. But feel free to use the object-oriented style if you think that's your thing. So for me, it's more like I use the object-oriented capabilities when that's the only sensible thing to do, when it's mandated by the problem I'm trying to solve. Right, so this is a rather big topic. So I've decided to split this lecture in two. In the first part, we will cover real sort of proper classes, and then in the second part, we will cover interfaces and type constraints, etc. And I will also assume that you are reasonably familiar with object-oriented programming and how that works, because I'm not going to cover object-oriented programming in this lecture. I'm just going to show you how to do it and what the syntax is and what the concepts are. But I'm not going to try to explain what polymorphism and virtual dispatch and so on. So if you don't know object-oriented programming, don't despair. You don't really need to know it. You can become a really good F# programmer without knowing anything about it, and you just use the bits that you need. All right. So let's have a look at how you define a class in F#. Not surprisingly, you start with the keyword type. And we've been doing a contact info both in previous lectures, and we've been doing it in the sort of live sessions and live coding sessions. So I'm going to build on that class since we're sort of familiar with it. So contact. So I could say type contact now and then equals and make it a record type. But in order to turn this into a class, I write a parenthesis. And if I want to make a really simple class, I can just say parenthesis equals, and now I can start building my class. So this would say this. What this says is that this type has a constructor, which is an empty constructor. It takes a unit, and that's it. But that would be a little bit silly for our contact class. So let's do something. I'm gonna, to save myself from typing, I'm gonna make this sort of a little bit of a shorthand. So I'm gonna say, okay, contact takes a first and a last. And you see, this is a tupled. These are tupled arguments, and then we're gonna have contact method. And for those who attended the Zoom session today, they should already know what this thing here is, this question mark. And this is something that is available when we are doing object-oriented stuff in F#. This tells us that this is an optional argument. And that is something which is not available in just normal function syntax. So now we can do optional arguments. So this says type contact takes 3 arguments, and it will later figure out that this is a string, and this is a string option. All right, so these are the arguments to the default constructor now. So, what can we do with this class? Well, let's go from sort of top to bottom, because there's a certain order enforced on things in a class. So let me look in my cheat sheet. Okay, so first of all, let's start by dealing with this method, which is the contact method. So I could say let method equals, and then I have a little helper function, which is in the standard library, which is called default arg. You can just write it yourself. It's just the option type. But then I can say default arg method, referring to that method there. I should probably call this contact method, but whatever. And I'll just give it the empty string. So now I have, with this let binding here, I have created a private immutable variable which is available only inside this contact. I can't access this. This is not a property of the class. This is not something I can access from the outside. This is an internal definition, and it's immutable since there is no mutable keyword, and I'm just looking at the whether this argument exists. I can say, okay, if it doesn't exist, I will just turn this into a empty string in this case. So let's create some internal state. This is already, now we're gonna move over into the dark side. So mutable danger equals, what did I use here? I used something like, well, I just turned this into a bool in my example. All right, so now I have a internal mutable variable inside my class. So now I can actually have state in the class. So now this is now we've moved away from the sort of pure functional world already. So if I'm gonna put some, if I'm putting some methods later on this object to modify this, this would typically be called the backing store. Right. So this is the sort of the storage backing up the properties that, or the getters and setters and so on of this class. So here is a simple backing store which lets me flip between true or false. Okay. Yeah, before we move on, we should probably talk a little bit about constructor. Because really what I have now is a very simple constructor. It's doing absolutely nothing. All it does is it makes these things available inside the class. So that's it. So they're just available as constants. I can't do anything. I can't do really much else with them. So if I would like to have a class that I could, for example, modify the first name and last name and so on, and later have the whole thing mutable, then I would have to create a mutable variable for first name and for the last name and method, and then create the proper methods to change those. But if I want to keep this thing and say, okay, once you've created it, first name and last name can never change, then this is fine. But the only thing that happens in this constructor is, yeah, this. But sometimes you actually think, okay, I actually need to do some initialization, and you might have to, I mean, you can create an object that needs to contact some database stuff and do all kinds of things in order to set itself up. How do we do that? Well, then after having these lets, which need to come first, F# has inside the object, you can say do, new line, and we indent. And here I can do all kinds of things. I/O, call databases, launch rockets, whatever needs to be done, modify mutable state if need be inside this object. So this is basically where you can add a block of initialization stuff that goes beyond just setting some immutable names. The only important thing is that this do block here needs to return unit. It cannot return anything. It just does stuff internally to the object and then it returns nothing. So you can, for example, one of the silly things that you can do in the do block is to say print hello. So every time you create this a new contact, it will say hello, if you find that useful. We can also create our own explicit constructor, so we can have an alternative constructor for this constructor. So that is by using the keyword new. Oops. So I could create, for example, a constructor, alternative constructor here, which doesn't take any arguments at all. And it could do whatever it needs to do. In addition to this do block, I could do some stuff. And the last thing this thing needs to do is that it needs to call it needs to call the default constructor, which is just called contact. So I need to call contact, and then I could say, well, okay, first name is empty, last name is empty, and that's it. And I don't give any contact method. So the last thing it does, any constructor, is to call the default constructor. So now I could create an object from this by saying contact parentheses parentheses, and then I would get a contact object with first name would be empty string and the last name would be empty string and method would be none. So that sort of covers how to construct an object. And now we could construct this thing. So I could say somewhere down, well, going back up here. So I could say let C equals contact, and I would create an object. It would print hello, and it would set up this object with this backing store and everything. Okay. But this is a pretty useless object so far. Because what can I do with this thing? Currently, nothing. Absolutely nothing. I can't read out what the method is. I can't see what the danger thing is, and there are no methods on it. I could actually turn it into a string because every object inherits from obj, which has a toString method on it. But that's it. That's all I can do with this thing. So this one is completely dead and boring yet. So it can't do anything useful. So let's try to rectify that. Okay. So suppose now that I still just want to have a immutable object. And but I want to be able to read out the first name and the last name. So now I can actually define members on this type. These are methods, but these are just accessors, so they don't really. I'm just gonna say member, And now comes a little bit of syntax. Now I need to give a handle. So I like to call it X. Some people like to call it this. If you're a Pythoner, you will call this self. You can call it whatever you want. There's no like special name for this, but I'm just going to call this dot first name equals first. So what I just created is a property, which is something I can read. And that's it. It's immutable. There's no, like, this is completely immutable. But it takes this value from the constructor and saves it up in this name here. And now I could have this C up here. I could say C dot first name to print out the first name from the object. So now I can actually do something with this object. And of course now I can do member this last name and member this middle name and use this default value or however I want. So then we have this danger. I said we have this member danger that we can mutate. So let's see how could I actually have something that I can read and write so that it's not just reading. So then I could say member. So that's member. This dot danger equals, let's see how this goes. I do this so seldom. Oh yes, so I can say with get, and get is a function which takes 0 arguments. It just takes this unit argument, and it is equal to this. So now I'm using this handle to refer to the object itself, right? I'll talk about this more in a later what this actually means. This dot danger, and then I have and set equals, and then I need to set X of course, and then I need to do this dot danger mutate with the new value. Of course I could make some much more elaborate set functions which will do all kinds of sanity checking on things and transforming and blah blah blah. So this is the simplest one where it's just I'm just saying okay, just mutate the whatever, put it in. And it, of course, since it already knows that this danger was a boolean, this is a boolean, and there's not really much sanity checking to do on a boolean. Either it's true or false. So it can't really, there's not much cleaning up to do. So, depending a little bit on your needs, you might be in a situation where you end up having to do a lot of extra work because you need to create the backing store, and then you need to create these getters and setters and implement all of these things. So that becomes tedious, and it's just nonsense to do it by hand. So F# actually has a little extra syntax to make this in one go. So you just do it super simple to have mutable or immutable properties. And the way you do this, so I will create the danger too. So I can say, or we could just call it, yeah, whatever. Member. And then you add this little keyword val, member val, which is member value. Equals, and now I'm not saying this or anything like this. I'm saying that I will create a member value and I give it a default Oh, I should give it a name, of course. Member val, we could call this full. So this is the member val full name, right? And that I could say equals, and then we can say, oops, first plus space plus last. Yes, and then I can say with get set. And now what this will do is it will create a string backing store mutable variable for this full, which will be called full, and it will actually create the getter and setter methods for it automatically. And of course, if you just want to have a setter or a getter, you just say with get or set. So, yes. So these are member values. So now this is how you this is the preferred way of sort of doing mutable properties. Or also you can also easily do immutable properties this way. Okay. So we know those. Classes can also have static members. So static, and those we create. So a static member, for those who, just a little reminder, a static member is a method on a class which doesn't require an object. So it's just a function that you can call, but it's sort of wrapped up in the class, namespaced by the class in a way. And those you create by saying, instead of saying member, you say static member. I had some, well, let's call it hello x equals x, or we could say print hello %s x. Right. So this hello thing will just print whatever, and right. Silly little function. But the thing is that I can actually call this. I can just I can't say now I have this C. I created an object on C. I can't say C.hello because the object itself doesn't have it. So now I have to say, to call this thing, I have to say contact dot hello. A string. And in fact, F# modules are by and large implemented in the .NET system as static classes. So there's very little differences. If you create a class which has only static members in it, you basically created a F# module, more or less. Yes. So that was static members. So the non-static members, they were always prefixed by this dot or x dot or self dot or foo dot or whatever you want to call it. So in principle, I could take something like make a static member which would be behaving more or less exactly like a proper member. And the way I would do that is that I could take this hello x. If it needs to access some stuff internal to this object, then I could just pass it in the object. So I could say this x equals. So that's sort of the essence of the. I haven't really experimented and checked how far you can push this, whether you can actually access the internal private stuff. I assume you can, but I haven't, so there might be. So just, caveat. Terms and conditions apply. This is not the stuff I do every day, so usually I just settle for using functions. Anyway, so one of the important things that when you do object-oriented programming is able to do polymorphism and being able to override and inherit. It used to be back in the day when I started doing object-oriented programming, it used to be inheritance was used everywhere for everything, and it was like inheritance, and the worst thing I've ever seen was 24 levels of inheritance. Like it was just in C++, and yeah, that was not good. So people realized that if you need to go more than 1 or 2 levels deep with inheritance stuff, you're probably in the woods already. And these days, composition is always favored over inheritance. And composition is, by the way, going to be the topic of pretty much a large part of the rest of the course. We're going to talk about composition in various forms, and straightforward composition and more advanced composition. So, but composition is the way to build complexity. Inheritance is the way to create complexity. Well, yes, so you've been warned. Right. So how do we create stuff that we can override? Well, by creating abstract members. An abstract member is a member which doesn't have any implementation. It's left up to the person who sort of wants to do something with it, with a class. If you want, you need to provide the implementation. So I can say abstract member show. So this will be an abstract member to show some stuff. It will just print it in some way, right? So and this is, I'm just going to say, okay, I need to just give this a signature. So I'm going to say this takes unit. Oh, I ran out of space. Unit to string. Right. So this is this abstract member. So you say c dot show parentheses, and it gives you back a string representation of a contact. But of course, this is not doing anything. This is abstract. So so if I would leave this like this, then this would be an abstract class. Like if I have an abstract unimplemented method in my class, then it's an abstract class, and you can't create an object from it. Then you need to inherit from it, which I will show you in a second how to do. And once you've inherited from it, you can implement this member. And once you've implemented the member, then you can create an object from it. But luckily, I can say, well, let's see how we did this. I can say default this dot show equals hello. That's a little bit boring, but okay. I can just have it say this dot full, which we already implemented, right? As a member value. So that's my default implementation of this thing. And I'll show you how to override this in a second when we do inheritance. But actually, I have this class contact. Every class in this .NET world will inherit from a superclass called object. That's like by default. There's nothing we can do about it. It's always there. And that comes with a method which is called toString, which is to give a string representation of the object. And in fact, I can actually override that for my class so that it can print itself in some nice way. So I can say override. So now I show how to override stuff because that is an abstract method with a default implementation in object. Now I override, and let's see how we did this because I never do this. This to string equals this show. So I'll just dispatch that to show directly. Well, I should actually not do that because this, yes, to string, it works. It's good. Yes. So that's how you override functions. All right. Okay. So now we created this class. And suppose now that I want to have one which has a slightly more elaborate way of showing the stuff. Print itself in a nicer way. So now I can actually inherit from this class. Okay. So type. I'm going to create a new class. I'm going to call it pretty contact. And I give it first, last, and this one I don't care about. I don't have any for the pretty contact. I don't have any contact information. Just first name or last name. Right. And then I say inherit contact first, last. So I need to call. I say inherit, and then I just call the constructor of the class that I'm inheriting from. First. Okay. And now I can say, okay, override this show equals, and then I have some function that I've implemented somewhere, which I will just call pretty print. So here you have basic inheritance with overrides. So now I can create two types of objects. I can say let contact1 equals contact bar, whatever, okay, and I can have a C2 equals pretty contact, and I can just give them the same arguments to those two, and then I can say, okay, print %s, comma %s. So I'm going to print both object, and I can say C1 dot show and C2 dot show, and they will print things differently. So this will use the pretty print, and this will just use the simple print. But this is a subclass of that guy, so I could actually make this C2 print exactly the same as this guy by using the upcast operator, which we'll see when we're talking about interfaces is a very important thing. Which means that I can say C2 colon angle bracket, and then I say contact to say that I upcast this to a contact class dot show So now I can convert it. And there's also one which is called colon, and this is a static thing, so this happens compile time. But there's also a version of this which allows you to downcast and cast things to whatever, but then you need to be careful because that might not be, you need to know what you have. Yes? So I think this is classes, more or less. Yes, one thing I haven't actually mentioned with classes and that's an important feature, if we want to do overloading, function overloading. And we can do function overloading for both static methods and for normal methods. It doesn't matter. So let's look at function overloading. I did this during the Zoom session today, but let's repeat how this works. So I'm just going to do some really simple. Suppose we have some. This is inside a. Sorry, should not be let. Member. And we're just going to call this F. One of the things is that when we're in the function world and not inside a class, we prefer camel case. We start with a little letter and then but inside of classes it's preferred to have things Pascal cased, which means that you start with a capital letter and then you go first name instead of first name. Right? So I'm just going to call this function f. Oh, sorry. This dot f, and I can say, okay, x is an int equals something. Now I can say member this dot f, x is a string equals, and I can do a string version of it. They have the same name, and the compiler will automatically figure out which one to do. There is a restriction, and if I would do something like a version of this with 2 arguments, I need to have them tupled. I cannot use curried versions, the one where I have a function returning a function, then that's an error. So if you want to do overloading, then you need to use the uncurried form. So I could have an x and y comma int. Otherwise it won't work. But that's basically it. And in fact, I can do things like this, and I can also do members or static members with optional arguments. So I could have some y float on that. This gets automatically this y, the type of this thing here. Well, that would be a float option, really. Yeah, so once you put in the question mark, it turns it into an option type. And then you just deal with it like either pattern match or use default arg function or whatever you do. Yes, so this is classes. And at least in I know that some people are, including Dom Syme, is very happy about. I think this is very super useful. I think it's useful. There's some stuff that is you absolutely must have these things in order to survive in a big project. But I think 90% of the code that we write has no classes in it. That's sort of a, I think, estimate of. So it's definitely loads of this stuff is not something we use every day. Like, I can't really remember when I wrote a real class. In the next lecture, I know I will talk about interfaces, and those I use quite a lot because they are very useful. Okay.